Hey everybody, it's Miss Marina and I'm back to talk to you this week about measuring and drawing angles using a protractor. A protractor is a tool that's going to help us to measure in degrees. In a lot of ways it's like a ruler because it measures with a unit, only instead of measuring in a straight line measurement, it's going to measure that circular opening. And we learned last week that there are 360 degrees in a circle. We're going to be using what's called a half circle protractor, so it's going to measure half of that 360 degrees, 180 degrees up to a straight angle. First thing we want to teach students when they're using a protractor is that just like using a ruler, we're always going to start at the zero. The only problem is that there's two zeros here, one zero over here and one over here. And there's one on each side so that students can use this to measure things. This one says down here, use this side for angles that open to the left. And we're going to use this side over here for angles that open to the right. So we can sort of count from either direction. And we're going to do two different skills here. We're going to do drawing an angle given a number of degrees and then measuring an angle that is already given to us. So this first one we're going to be doing is angle CBD that measures 60 degrees. Step one is to line up my vertex point right here with this little dot right there in the center. And I always want to make sure that my line lines up with this zero line. So see how it's crooked right there? Being off by even a slightest bit will mess up our angle by quite a bit. So I'm going to line that up, do this as best I can one-handed. And I want 60 degrees. So instead of just finding the 60, because there are two 60s on here, and this is a big mistake students make, there's a 60 here, and there's a 60 over here too. In order to not just look for that number, we're going to count up from zero until we find that 60 degrees. So starting here at zero, that's 10, 20, 30, 40, 50, 60. Okay, I'm not going to start counting down from 180. So 10, 20, 30, 40, 50, 60. I'm going to put a mark right in here. And then I'm going to use a straight edge to connect my mark. This is where it's going to be tough for me. This isn't going to be very straight because this is one-handed. So we're going to connect that and then put our point up here. Now this forms an acute angle, so that's a double check that my 60-degree angle used the right number. If I had used the other 60 over here, I would have opened up to an obtuse angle. So this acute angle is measures 60 degrees, and last week we had some confusion from students on the difference between classifying and naming an angle. This is classifying an angle, describing what kind of an angle it is. Naming an angle uses letters and points, where my point right here, my vertex point that forms my angle, is always going to be made up of that middle point. So this is going to be angle B, this can be angle C, and this can be angle D out here. So this can be called angle CBD or angle DBC, with B always at that middle point. All right, we'll try another one here. This is going to be angle NPS, which opens to 115 degrees. That's an obtuse angle. I'm going to open this one the opposite way so you can see using the other side of that. All right, so I got my vertex point lined up. Again, making sure my zero is nice and lined up with what's going to be the bottom part of my angle. Okay, and I want to go to 115. Not just finding 115, but remembering we're counting up from zero. So this time I'm using these numbers up here. 10, 20, 30, 40, 50. It's going to go past 90, 110 to 115. There's no 115 written here. Each one of these counts as 1 degree, and there's a medium mark right here in the middle. That's going to give me my halfway point between each of these 10s. So 115 degrees can be right there. I'll make a mark. I can hold it down with my paperweight here. Okay, and then I'm going to connect. Okay, so again, this is my double check. I formed an obtuse angle. That means I did use the right number. If I had used the other 115 degrees, I would have been, like over here, that would have formed an acute angle. So we want my middle letter to be my vertex point. That's angle P. This can be angle N out here, and this can be angle S. Okay, this can be classified as an obtuse angle, but it is named angle NPS or angle SPN. All right, now these next two angles are already drawn for me. I'm just going to determine the number of degrees. These can actually be tougher because what students will often want to do is just go straight to that number. So I'm going to line up my vertex point, line up my zero, use it as my starting line. All right, and Again, if students just go, okay, I got it all lined up, I'm just gonna find that number. Again, there's two sets of numbers here. I've got in between the 40 and 50, and in between 130 and 140. But remembering here, I'm counting up from where the line touches 0. So I'm gonna count 10, 20, 30, 40, halfway between 40 and 50 is 45 degrees. And it's an acute angle, so that number should be less than 90, that makes sense. This is named angle HIJ, or angle JIH, measuring 45 degrees. All right, and then here's another one. This is going to be an obtuse angle, so I'm going to want a large number here. Okay, got my 0 lined up. This time we are going, again, don't just go straight to that number, because what students are going to see is this line comes all the way out here, and they're going to want to pick 50. If I pick 50, I'm really measuring from outside of this angle. Starting from over here at the 0, 10, 20, 30, 40, 50, 60, 70, 80, past 90, past a right angle, past 110, 20, over to 130 degrees. Okay, so angle MNO, or angle ONM, measures 130 degrees. All right, the next thing we're going to do is we're going to talk about decomposing an angle. We talked about decomposing fractions. Decomposing just really means breaking down a sum or a total into parts. We're going to be doing that with angles, whether we have to use or don't use a protractor. So all of these examples I'm going to use today, I'm actually not going to use a protractor for. So if we have this angle and it measures 70 degrees, to decompose that, that means 70 degrees can be equal to the sum of a lot of different things. Okay, this could be a 60-degree angle plus a 10-degree angle. That could equal 70 degrees. I could split it right in half and make it a 35-degree angle plus a 35-degree angle. Units important here. I could make it a 20-degree angle plus a 50-degree angle. Okay, all of those will equal to 70 degrees. So what that would mean is if I wanted to do a 70-degree angle and split it in a number of these ways, for example, if I wanted to do this last one, 70 degrees, split into 20 and 50 degrees, that would mean that, sorry, I'm getting under the lights here, I would find where my 20-degree mark was right here. Okay, connect my vertex point through there, and I basically broken this up into this being 20 degrees and this being 50 degrees for a sum of 70 degrees. Now I didn't have to measure this angle to know that. I've used math here and algebra. But if I wanted to look at this one also, notice I have to rotate my protractor a little bit. My line wasn't super straight. 0. Okay, you can see there's 50 degrees right there. Okay. All right, so this next one gives me the two angles of these two together. And the question would be, what is the measure of angle NPO? All right, so angle NPO, that's N to P and P to O. So that means we were trying to find the measure of this angle here. So I'm going to combine those together. I could write in an algebra expression, 40 degrees plus 80 degrees. So the measure of angle NPO is going to equal 120 degrees. So this is an obtuse angle, that makes sense. And that would be sort of the reverse of doing a decomposing angle, taking two angles and putting them together to find a sum. All right, here's another example. This time we're told angle A to D to Z. C is 110 degrees. We're told what this angle is, and we're using algebra and a number expression to figure out this unknown, that N standing for a variable, number of degrees there. So two ways we can do this. We can do it with addition. 50 degrees plus some number of degrees equals to 110 degrees. All right, and then using inverse operations, we can also flip that around. And we could say 110 minus 50 degrees equals some number of degrees. So the measure of angle ADC whether I'm using an addition, sort of a count up strategy, or whether I'm subtracting, is going to be 60 degrees. And I don't even have to use a protractor to prove that point. All right, the next one's going to be kind of similar, only something has to be understood and is not stated here. So this time I need to figure out this number of degrees here. This is my variable. So 20 degrees plus some number of degrees equals, and students might be saying, well, I don't know what the total is. Down here you told us the total number of degrees was 110. Okay, well, this is an angle that we learned about last week. This is a right angle that we know measures 90 degrees. So once I see that square in the corner, or I recognize that right angle, I have to know right away that this is an angle measuring 90 degrees. So I can think about it as addition, or I can flip it around using inverse operations. 90 degrees minus 20 degrees equals some number of degrees. All right, so the measure of angle A, oops, not A, sorry, DB, let's change that. Angle DBC is going to be 70 degrees. I was about to say ABC. You see, A to B to C is the one that we recognize as 90. That's why naming these angles with points becomes so important, so you know which of these angles you're talking about. We're not just talking about angle B anymore, because angle B could mean this one, or both of those together, or the reflex around the outside. So using these points helps us to know whether we're talking about ABD, DBC, or ABC. All right, here's an example of one we are told. Angle RSU, that's RSU, is 150 degrees. That tells me all of this is 150 degrees. I'm trying to figure out this unknown angle here. So it's going to be some number of degrees plus, again, this is the part that has to be understood. I see that there's 90 degrees. Okay, it's not going to be stated with the number. Students have to recognize that. So some number plus 90 equals 150 degrees. We could also do 150 degrees minus 90 degrees equals that sum number. Okay, so the measure of angle RSU is going to be, my pen's failing me. Good thing we only have one more question. 60 degrees. All right, and then the last one, which has an understood component to it. We have 35 degrees here. We have 45 degrees here. Oh, I should put letters here. We'll call this M and N. So we have angle JKM, that's 35 degrees. Angle MKN is 45 degrees. We are trying to determine what is the measure of angle N, K being the middle letter, L. Well, students might say, well, I can add 35 degrees plus 45 degrees plus some number of degrees, but in order to figure out that sum number, I'm going to need to know what this total is. Well, we can also see these three together form a straight angle. That's a half of the circle. I put that in there, I can see that that is 180 degrees. They may not have a protractor for that. They're just going to have to look at that and recognize that right away when they see that straight line as 180 degrees. All right, so 35 plus 45 plus some number equals 180 degrees. Easier way to solve this, if you had to treat it as subtraction, 180 degrees minus the sum of those, 35 plus 45. It's going to be 80 degrees. So 180 degrees minus 80 degrees is going to equal 100 degrees. And so the measure of angle NKL is going to be 100 degrees. All right, thank you so much for watching. Using a protractor and decomposing angles and problem solving to find unknown angles. Go ahead and like and comment. And we will have our test this week on Friday.